This video is for class 6 mathematics, and in this video we are discussing about powers of literal quantities or power of literal quantities. When a quantity, it can be any number or any alphabet, is multiplied by itself, okay, by the same number, okay, and it can be multiplied many number of times. So the product is called a power of that quantity. Product is called the power of that quantity. Now this product is expressed by writing the number of like factors. That means the same number should be multiplied again and again, no addition, no subtraction, okay. In it, to the right of the quantity slightly raised, that means like here at the top, slightly raised at the top. Now for example, a into a has two like factors, that is a and a. So to express it as a into a, I can write it as a raised to the power 2. So we pronounce it as a raised to the power 2, like it is written here, a raised to the power 2. So going to the next example, similarly a into a into a, there are three a's, so there are three like factors. So in that case, this a into a into a into a into a can also be written as a raised to the power 3. Now a into a into a into a into a, there are total 5 a's, okay, they are all like factors, so we can write it as a raised to the power 5. So following table will make the concept more clear. Suppose we multiply a into a, right? So a is the like factor here. It can be written as a raised to the power 2 or a square. Similarly, if I multiply a 3 times, then I can write a raised to the power 3, okay, or I can pronounce it as a cube or a cubed, right? We shall use this particular sentence, it will be more easier. It is the general form to express the power. Now 1 2 3 4 5, there are 5 m's, hence m raised to the power 5, okay, or the fifth power of m. So now here you can see that if a number or any alphabet is being multiplied many number of times, the number of times should be written at the top, okay, and what is being multiplied is written at the bottom. So suppose we have a which has been multiplied 8 times, so a has to be written down and 8 has to be written at the top. This a, the bottom one, is called the base, whereas 8 at the top is called the exponent or index or power, right? But for the time being we shall use the word power. Similarly, in x raised to the power 5, x is the base, right, whereas 5 is the power. We will put the habit of using the word power in class 6, right? We are not using exponent and index, okay. Now for all values of x, that means 1 2 3, for any value of x, okay, it can be decimal number, it can be any number. For all values of x, if it has power 1, okay, then that will be equal to x only. For example, if 5 has power 1, if I solve it, I should get 5. If 8 has power 1, it will be 8 only. If 35 has power 1, it will be 35 only, right? I hope you are understanding. Now the next rule of this exponent, or you can say index or power, is for all values of x, it can be 1 2 3 for any number, okay, if it has a power 0, then the answer will be 1, For example, here 5 raised to the power 0 is 1, 8 raised to the power 0 is also 1, 35 raised to the power 0 is also 1, and so on. Okay, let us take a few examples from the book. First example, write each of the following product in the index form, okay. We shall do one example each, that will be enough, right? So write each of the following products in the index form. So here 1 2 3 4 5 6 things are given. The first 2 things are m and the next 4 things are n. So how can I write this? We can write this as m raised to the power 2 multiplied by, or if there is no sign, then I can write m raised to the power 2 and n raised to the power 4. So similar, this also can be done. Okay. Now going to next example, write each of the following in the product form, right? So already we are getting in the power form, right, index form, 3p raised to the power 4. So 3 multiplied by p how many times? 4 times. That is in the expanded form. But we are not doing this kind of sums in algebra right now. We shall do actually the degree of a polynomial. Let us try to understand what is that. So we have come to the topic polynomial in one variable and its degree. Polynomial in one variable and its degree. Okay. So let us try to understand this. So when an algebraic expression is made of only one variable, okay, then it is called polynomial in one variable. Polynomial in one variable. For example, here we have an algebraic expression which is 3 plus 5x minus 7x square. So only x is out there. No other alphabets are being used. So this kind of algebraic expression is known as polynomial in one variable. Polynomial in variable x. There is only one variable. The next example will be 9y cube minus 5y square plus 8. Here also there is only one alphabet, which is y. So this also becomes polynomial in one variable. So it is a polynomial in variable y only. Right? Then we have to learn how to find the degree of the polynomial. This is our main topic. Degree of a polynomial in one variable is the greatest of the exponents power of its various terms. For example, here let us take this example. Y has power 3, y has power 2, and there is no y only at all. So what will be its degree? Its degree will be 3, the highest power. Since the highest power is 3, so degree is 3. Degree is 3. So we call it as degree 3. Sorry. REE degree 3. Okay, DEGREE degree 3. Right? So degree of this polynomial here is 3 because the highest power is 3. Right? Now there are few other examples given to us. Let us try to understand. For example, for polynomial 4x square minus 3x raised to the power 5 and plus 8x raised to the power 6. There are 3 terms and each of them having different power. I have to choose the highest one. The first one is 2, the second one is 5, and the third one is 6. So the highest is 6. Since the greatest exponent or the greatest power, since the greatest exponent or the greatest power is 6, so the degree becomes 6. Right? So the degree becomes 6. You just have to check the power, take the highest power, that is my answer. Therefore, the degree of the polynomial, the given polynomial is 6. Okay. So now let us try to understand other examples also. Number 2. The degree of the polynomial 25 minus x to the power 4. Right. So here 4 is the degree. Why? Because that is the highest power. And remember that power should be of the literal alphabets, not of the number. Next, number 3, the degree of a polynomial 5x minus 3 is 1 because there is no power. If there is no power, it is supposed to be 1. The degree of the polynomial here, this one, 4x cube minus 15x raised to the power 5 and 7x raised to the power 8 is 8 because that is the highest power. This is true for polynomials in one variable. This is true for only the polynomials in one variable. But that is not enough. Okay, there are other polynomials also with 2 or more variables. Let us try to understand how to find their degree. Okay, suppose we have a polynomial of 2 or more variables, right, and we have to find its degree. Let us see how to solve it. Suppose a polynomial is given to us, 3x plus xy square minus 8yz. Here is a polynomial. Okay, this one is a polynomial, but it has two kinds of variables, that is three kinds of variables, that is x, y and z. So it becomes a polynomial with three variables, right? That is x, y and z. If I take another example here, 5y cube minus 3y square x plus 8x square y square minus 3x raised to the power 5. Here we are having two kinds of variables, so it is a polynomial of two variables, that is x and y. So in order to find the degree of this kind of polynomial, such polynomials, okay, there are two steps, right? Number one, the sum of the powers of all the variables used in each term of a given polynomial. First find the sum of the powers. I'll let you know how to find the sum of the powers. And number B, the greatest of this sum is the degree of the given polynomial. So let us try to understand this with the help of example. For polynomial here, 3x plus xy square minus z, it has three terms, and for each term I shall find the power. Since the sum of the powers of the variables 3x, there is only one variable 3x, it is 1 only. Okay, so first term has power 1. The sum of the powers of the variables in the next term, this next term here, so it should be 3. Why 3? Because x has power 1, whereas y has power 2. So 2 plus 1 will give me 3. So the next term is having power 3. Okay. Now let us go to the last term, which is minus 8yz. The sum of the powers of the variables yz is 1 plus 1, because y also doesn't have any power, z also doesn't have any power. So if they don't have any power, so it will be 1 and 1, which is, if I add them, I should get 2. So here 2. So first term is 1, second term is 3, and third term is 2. So what is the highest power given to us? Is 3. Hence the degree of the polynomial becomes 3. Hence the degree of the polynomial becomes 3. Now let us try to solve question number 10 from exercise 18b. Coming to question number 10 here, write the degree of each of the following polynomials. Okay, I am supposed to write the degree of the following polynomials. Now we can go to number 1. Okay, we are going to number 1. The question number 1 is x plus x square. X plus x square. So this x has degree, this x has power 1, whereas this x has power 2. So what is the degree in the first one? So first one has a degree of how much? Degree equals to 2. Okay, because 2 is the highest power here. 2 is the highest power here. Right. Now I hope you understood number 1. Let us try to do number 2. Going to question number 2 here. Okay, the question reads as 5x square minus 7x plus 2. So this x has power 2, this x has power 1. If there is no power, it should be 1, right? And this 2 doesn't have any x only. Okay, so what should be the degree of number 2? Number 2 degree must be equal to 2. Degree must be equal to 2. Let us go to the next one, which is number 3. In question number 3, right, we have first term having the power 3, second term having the power 8, third one having the power 10. So what should be the degree of this whole polynomial? It should be 10. 10 is the highest, right? It should be 10. So number 3, degree is equal to 10. Please do this in your exercise books. Okay, now you can go to the next number, which is question number 5. Question number 4. Question number 4. So question number 4 reads as, okay, question number 4 reads as 1 minus 100x raised to the power 20. So obviously this 20 is the answer, because that's the highest power. So number 4, degree equals to what should be the degree? Degree equals to 20. Okay, I hope you understood this. Now let us go to question number 5. In question number 5, here you can see the highest power of x is 3. Obviously, directly here there is 1, here there is no x only, so it should be 0. So maximum is 3 here. So degree equals to how much? 3. Degree equals to 3. I hope you understood till here, right? Then we can go to the next number, which is question number 6. Till number 5, all the questions had only one variable, so they were the polynomials in one variable. Right now we can see there are two types of variables here, x and y. So in this case, what is the first term? What is the first term having the highest power? So x is having 2. If there is no power, y will have 1. So this 2 plus 1 will give me 3. Okay, and going to the next term, it is 2 only, because there is only one variable. Out here it is 2 and 5, so 2 plus 5 will give me 7. So out of these 3 numbers, these 1, 2 and 3 numbers, which is the highest power? Obviously 7. So what's the degree? So degree must be equal to 7. I hope you people are understanding. Let us go to the next number, which is question number 7. Okay, question number 7. Now the first term has only 3 as the power. Second term is 2 plus 3, which is 5. Sorry, it's 5, right? And the third one has 5 and 1. If there is no power, we need to consider it to be 1. So 5 plus 1 will give me 6. So what's the degree of number 7? Degree. So degree should be equal to 6. I hope you understood till here. It's quite easy, right? Let us go to the next one, which is question number 8. Okay, the last one. Here the first term has power 2, second term has power 3, and third term you can see has power 7 plus 2, which is 9. So what's the degree? Number 8's degree. So number 8 degree must be equal to 9, right? I hope you have understood. Okay, this much for this video. Thank you so much.